Hey, hi, good evening, friends. Hope everyone is doing well. Right. So, what did we discuss in the last class? In the last class, we have understood the concept of K-means algorithm, one of the widely used clustering algorithm in real world. Okay. So, first of all, what is clustering, friends? What do you mean by clustering? Clustering is nothing but grouping. Grouping similar records. Okay, you are supposed to group the similar records, and how do we identify that the records are similar, or how do we identify the similarities between the records? We identify based on distance calculation, right? So clustering is nothing but grouping similar records. And how do we identify the similarities between the records is, or how do we identify the similar records is by calculating the distance. If the distance is less between the records or between two data points, their similarity is more. Okay, if the distance is more, the similarities will be less. So this is how distance and similarities are proportional to each other. Both of them are inversely proportional, and we have to by default use the distance formula. And in our case, we'll go with the Euclidean distance. Okay, so Euclidean distance is given by square root of x1 minus x2 whole square plus y1 minus y2 whole square. Right, so we have to use a Euclidean any distance formula. It's not only Euclidean distance. You can go and use any one of the distance formula, and this particular distance formula will be used to calculate the distance. Perfect. Right, so this particular formula gives us the distance, and if the distance is less, the similarity is more, and if the similarity is more, we can obviously group that particular records. So within a cluster, friends, this is a question for all of us. Within a cluster, assume that the data points are scattered in this way. The distance between the data points should be more or less. What do you see? What do you think? Should it be more or less? Less. Good. The distance between the data points should be very less so that the cluster will be tightly packed. Okay, then if you take one more cluster and if you have again the same data points, nothing but some records, okay, and this forms a one more cluster, cluster 1 and some cluster 2. Then the distance between two clusters, cluster 1, cluster 2, should be more or less. I'm talking about two clusters, not the distance between the same cluster records or cluster data points. What should be the distance between two clusters? Should be more or less? Good. It should be more. If the distance is more, so that you will get, well separated clusters. The clusters should be well separated so that the data points will not jump from one cluster to the other cluster. Why are we discussing all these things is we discussed the K-means algorithm yesterday. K-means clustering. What does K represent in K-means? What does K represent in K-means? K represents number of clusters. Am I right? Yes. Excuse me. K represents number of clusters that we have to define upfront. So upfront you have to define the value of K. Assume there are 100 records and say 5 columns in your data set. You decide how many clusters you want to come up with, or into how many clusters you want to group these 100 records. That should be decided upfront. Okay, so I want to just group them into three records. I mean three clusters. So if I keep k is equals to 3, what is the first step of k means? What is the step one of k means? Friends, be active. The first step of k means is, as I have yesterday told, concept plays a crucial role. Why? What is the reason for that? The reason is, in general, I'll talk about interviews. In interviews, okay, so especially when you go and attend any of interviews, right? So they'll start asking you about projects. What are the projects that you have worked on? So you'll start telling all your projects that you have accomplished successfully. Uh, you know, for example, you started with your first project, then they cannot ask you to showcase all the code. Okay, assume that your first project is customer segmentation. Okay, so will they ask you to showcase your code? Go get me your code, show me how it is done. Will they ask you such kind of questions? No, they can't. But how do they check that, in general, that we have done with this project, that we have actually, you know, performed or accomplished this project? What can they ask us? They'll start asking you questions with respect to your data first. Tell me the size of your data set. What are the number of rows and number of columns that you have? Don't be foolish. This is in general you can expect in real world. Akhil, will it be asked? Yes, my friends. True. The reason is they cannot ask you to showcase all the code that you have come up with. So they can check with the, probably with starting with the data, they'll go deeper, step by step. The process, the methodology, what you have used. Okay, then they also come into the concept level. That's how they check. Either you have done the projects on your own, or just for namesake you have kept in your resume. So they'll start from the scratch. The scratch is data. The basic step that we do is data, right? Obviously. What are the number of rows and number of columns? Why? Can again the question rises here. Akhil, I'll tell a random number for the data. Number of rows, number of columns. Okay. Assume you have told a random number. Okay. Again, they'll go and ask you how many rows did you keep for training and testing. Somewhere you'll be caught if you did not do the project. You know, somewhere when you're trying to explain, you'll be caught, because when you try to say random numbers, you can't memorize them for longer time. I hope you understood my point. So if you have actually done, it's better if you remember the dimension also. You can segregate accordingly, right? So this is how in real world the interviews will be. And for a fresher, yes, they can start you from this particular question. What is the size of your data set? Yeah, you have to tell number of rows, number of columns. Where did you store it? Is it in cloud, local machine, or any database? Yep. So you'll get follow-up questions one by one, one by one. Okay, if you are actually answering good, then they'll go to the concept. What algorithms did you do, or what algorithms did you actually use to build your model, to build your customer segmentation model? Again, immediately I tell K-means algorithm. Okay. So can you explain how a K-means algorithm works? Then you have to explain the process. That's why yesterday I told you concept plays a crucial role. Understanding an algorithm end to end is very essential in machine learning and deep learning. Don't assume, just for namesake, we are just understanding, then we are going to the project and doing all this stuff. You have to memorize. You may not grab the 100% of the concept at the single, I mean, at the first stage, but when you keep on attending, when you keep on listening to the same class multiple times, you know, you'll get all the concept in your mind. It gets fixed. Yes, that's how, people actually uh, get the concept, because these are algorithms, friends. How can we get, or how can we grab 100% in a single time? In general it's impossible, but if you are capable of grabbing 100%, that's very great. To be frank, that's very great, right? So if you don't really remember the concept, go back and watch the video again, watch the session, grab the concept, then do a project, work on a project. So today is our project on K-means algorithm. How K-means can be used for building a model on customer segmentation. All right, let us not go into that because we are running out of time, right? So, concept. What are the stages, or what are the working steps that we have with respect to K-means algorithm? In the first step, we have to initialize K centroids. What do you mean by initializing K centroids? Upfront, you will decide the value of K? Yes. So when you define the value of K, in our case it is 3. Okay. So upfront, you have to come up with 3 centroids. Centroid 1, centroid 2, centroid 3. Is there any rule for it? No. Randomly. Out of these 100 records, 3 data points should be marked as centroid. Okay, what is the second step? Calculate the distances, calculate the pairwise distances between the centroids and with all the data points. So first row with this centroid, second row with this centroid, so on. You'll calculate all the 100 distances. Then the same for this centroid, then with this. Once if it is done, wherever you have observed the smallest distance, start assigning to that centroid. You take one, the row one, calculate the distance with C1, one with C2, record one with C3. So out of these 3 distances that you have got, where you observe the smallest distance. Why smallest distance? Distance small, similarity more. So assume that I have observed the distance is small with respect to C2. Then record one will be part of C2 centroid. So this process will continue for all the 100 rows, and the third one is assigning. Assigning those records to the centroids. So to form a cluster, it forms a cluster. And fourth step is you continue step 2 and step 3 till the algorithm converge. Converge in the sense till it stops, because the process keep on happening. Why? if when the data points or records will be assigned to the centroids, they'll form a cluster. Once if the clusters are formed, it will start calculating for the new centroids, and again the pairwise distances will be calculated with the new centroids, then assigning will be done. Again the same process keeps on going. It keeps on going till when? Till it stops converging. That means till these centroids that you have, if they remain static, if they don't change, then obviously the algorithm stops. But what if it is not actually stopping? Then upfront you can define the number of iterations. If you define the number of iterations as some value, with some value, so by default it performs these many iterations and it stops. That's it. So this is called converging, and by default you can stop the algorithm by controlling the number of iterations, or by defining the convergence criteria we can stop the algorithm. The reason is, if you have a data point exactly lying to the center of two clusters, if your clusters are in this way, C1, C2, I mean cluster 1, cluster 2, cluster 3. Okay, so this cluster initially might be part of cluster 1. Once all the clusters got created, okay, then the centroids has to be calculated again. So might be the centroid is somewhere here. For this it is here. For this it is here. Then again you'll calculate the distances with all the centroids for the data points. When you calculate in the next time, you'll again the data point will be part of the next cluster 2. So in this case, the data points which are exactly at the middle of two clusters, they keep they jump here and there between cluster 1, cluster 2, cluster 1, cluster 2. So this, there is no never ending process for this. So how can we stop this? By fixing number of iterations. At 100th iteration to which this data point belongs to, might be cluster 1 or cluster 2, it will stop. It doesn't move here and there. Right? So this is how K-means work, but let us also do it on a real world data set. Okay, I have a data set where we are going to perform customer segmentation. And how can we upfront define the value of K? What are the different ways that we have? The old method is square root of n by 2. This is not preferred nowadays. Then we have elbow curve, or this is also called as tree plot, where we take different values of K and on the x-axis, and on y-axis we'll take inertia, nothing but within sum of squares for all the clusters. Okay, so wherever we see that elbow shape within the plot, so that K value will be considered with respect to elbow curve or tree plot. If not, we can also go with domain knowledge or customer requirement. If the customer says, Akhil, I want 5 clusters, not 3, you know, we have to go with the customer first. What is the client expecting from us? Okay, if there is any customer requirement, you have to go with customer requirement initially. You should not, initially think of 5 clusters doesn't work. Okay, probably the results will be worst. How can you tell that without performing the or building the algorithm, the model? So you build a model with 5 clusters, and if the results are worst, yes, you can say the same thing to client. You can convey the same thing to the client. Then customer gives an option to you. You take a call. How many number of clusters will actually make sense? So all these questions comes into the picture, friends. But initially, you cannot directly say that your number is not actually making sense. Obviously, they'll be in industry for several years, right? So one of the recent project that I have done is to a very famous client who is not a It's not a company. It's not an Indian company. Uh, Probably you guys are aware of European countries, right? Like how many of you are aware of Poland, Slovakia, Germany, okay, Romania. So in all these countries, European countries, there is a famous client. I mean, there is a famous company who is client of us, and this guy he runs a gaming industry. Yesterday I was asking you, how many of you are have invested your money in Dream 11, or there are n number of gaming platforms where we actually for entertainment we go and bet. So we have Bet 365, Dream 11, then Dafa Bet. What are these? All these are gaming platforms which allow us to actually bet. In the same way, our client is also running a, you know, he is actually holding multiple games where people come and bet. They play casino, okay, slotting. Okay, there are multiple games, friends, not one. There are n number of games, and this particular client, what we have done in the project is we are supposed to whoever is a new customer of this client, he initially gives some kind of bonus to the person who joins new to this particular games. Assume that if I'm new to this particular client, so if I register for the first time, I'll get bonus. So this bonus can be used, it's like money. Okay, so our client is spending around 1,000 crores for just providing bonus per month, in just one country. So I'm talking in INR. I'm not bringing their particular currency into the picture. In INR, he is spending around 1,000 crores per month, right? So this particular bonus has to be optimized, because there will be some folks who generally come to get this bonus alone and they don't play, right? That is altogether a different story. So we have to identify the right people for whom we can generally give bonus. So that's the project that I have worked on, the last project, and where we used clustering as one of the algorithm. It's not done in one phase. We have achieved the output in multiple phases. So in one of the phase we use clustering to make clusters, the similar records, to identify the similar people. We performed clustering, and with respect to clustering again, Akhil, which clustering algorithm did you work? I used around 12 clustering algorithms, friends, not one. Why? Why, Akhil? The reason is, you cannot tell that this one algorithm will work well for your data. Will K-means work well for your data? Who can tell that? Until unless if you work out, you cannot take a comment, right? So in that way, in the same way, I have experimented with the 12 clustering algorithms with the multiple approaches, probably different combinations. In total, I went with probably 350 combinations as per my whatever I have remembered. I think 350 combinations is what I have think. So different like removing outliers, then performing scaling, then performing k-means. This is one combination in that way. Okay, combinations refer in that way. But as part of this particular session, we'll be only working on just k-means, only k-means, right? So without further delay, we'll start our particular use case, our project on customer segmentation. Okay, if you have any kind of questions, all your questions will be addressed at the last, right? So I'm talking about end-to-end project, right? So end-to-end refers to, what do you mean by end-to-end? Starting from phase 1 of crisp MLQ till phase 5 of crisp MLQ. But in this particular project, I did not come up with deployment. So deployment, I'll explain for the next use case, the next project on supervised algorithm. Just for today, we'll go with evaluation. Till the evaluation part, we'll do for K-means algorithm. Right. So you see, this is the code that I have come up with. Don't just think of the size, because whatever we have learned in the previous 25 days, I have clubbed all of the topics that were discussed in one code. That's it. Oh, then it will be easy, right? So let us discuss all of these things. But before that, what is the data that we are working on? This is the data. So there is a mall, friends. Okay, so mall, when I say mall, generally into the mall, the customers walk in, they'll purchase, their requirements. Depending on what is the requirement, they'll go and purchase, right? So assume there is a mall, some XYZ mall, and this was the data that was collected in a specific mall. And what is the different columns that we have is the customer ID. This is just the ID that was given randomly to the customer. Instead of storing the name, we just stored with the name, with the ID for a particular customer. Then the gender of the customer, then age of the customer, then annual income in dollars. This is not a mall that is in India, and it is in United States, USA. Okay, so annual income in dollars per annum. What is their salary? It was recorded in dollars, so it is 15,000 US dollars per annum. Then spending score. So how much do they spend? Out of this annual income was given with a score. So if the score is high, their spending is also high. If the score is low, the spending is obviously low. So what is the use of collecting all these details? Yesterday I was talking, right? Customer segmentation is generally a project that was done in real world. For in each and every domain it is done, friends. Whatever domain you take, they they'll organize your data in the similar fashion, and they'll start performing clustering. Okay, so when they get good clusters, you will fall into a particular cluster, right? So depending on the cluster that you are being fall, they'll target you. Okay, so in the same way, I want to uh, form clusters using K-means algorithm, and then let us target the customers who are spending more, who are spending less. Why are they spending less? If they are spending less, let us give some offers to them. Okay, see, if the annual income is more and if they are spending less, what do you say? There might be some reason why are they not actually purchasing, right? There might be some cases like their annual income will be very low, but still they spend more. So those are the folks we are actually, they are actually giving us more profit. They are not even focusing on savings. They're completely spending their entire annual income. So for them, you have to come up with the different offers. So this is how customer segmentation helps us, and that can be done using clustering algorithm. Clustering is an unsupervised algorithm where we don't have labeled data. Is there any Y column to predict? No, there is no Y column. Am I predicting anything? No, right? But what am I doing? I'm going to perform clustering. I'm going to identify the similar records, identify the similar customers. Based on the similarities between these customers, I have to go and target our customers with some offers, with some discounts. That is my actual use case, right? So this is my data. What is the first step? The first step is nothing but importing the required packages. So whatever we have learned so far, everything I have kept in this particular .py file, the script. Don't get tensed. Don't assume it's a big one. It is just a small one that we have over here, but your focus is something important. Okay, so let's continue, friends. I'm importing pandas as PD for data manipulation, then matplotlib for data visualization, cbon for data visualization again. What makes the difference between matplotlib and cbon, friends? Matplotlib is a basic visualization module and cbon is an advanced visualization module. Then detail. So for the first time, we are listening to a new module called detail. This was not used so far, and what is the use of importing detail? And for sure, you will not have detail in your uh, you know local systems. The reason is detail is an automated EDA package. Automated EDA package. What is this? This is nothing but as part of CRISP MLQ. CRISP MLQ. What did we learn? We learned the first four phases. Probably five, six were not being discussed. So out of four, in which phase we had EDA? Second phase. In EDA again there are multiple measures that we are supposed to calculate: first moment, second moment, third moment, fourth moment, then visualization. Everything will take lot of time. Yes. So instead of doing in the same way, you can automate this, the entire process that you are talking about. Okay, you can automate with some automated packages. One of the automated and widely used package is Detail, automated EDA package. So it performs this entire EDA in a single go. Within two lines, all these can be done within just two lines. Is that possible? Yes. I'll show you, friends. Probably just 2-3 lines, you'll get the output. Okay, so Detail is an automated EDA package, and by default you will not have this in your system. You have to install it using pip. So again, when I talk about installation, what is the process? Visit PyPy repository, .pypy repository, and get the command, copy it, paste it in the console, then click on execute. So you have to install this particular package. Post installing, refresh the kernel and start importing that particular package. Right. So I'm importing Detail. I have Detail in my system. So I'm importing it. Let me show it to you. It's under execution. Importing Detail, it's done. Then what am I importing? Winsorizer. Oh, where did we use Winsorizer? Akhil, we used Winsorizer for outlier treatment, handling outliers. Yes. So same, whatever we have used, everything I have kept in one single code. I'm just importing Winsorizer, then importing one hot encoder and min-max scalar. One hot encoder is for encoding, creating dummy variables. First of all, do we have any non-numeric column in the data? Yeah, we have to, encode this column. Why? Because can you calculate the distance between male and male? No. When you cannot calculate the distance for a non-numeric column, you have to convert this non-numeric column to numeric column. And that particular process is called as encoding, dummy variable creation. For that purpose, I'm importing one hot encoder. Then finally, min-max scalar. Min-max scalar is used for scaling, friends. In order to bring all the features to a particular scale, we have to use min-max scalar. So this min-max scalar we have understood as part of feature scaling. So everything we have understood. Now comes the new, new function, that is KMeans. This is available in sklearn package, sklearn module. Under sklearn there is a submodule called as cluster. From sklearn dot cluster import KMeans. Okay, so I can build a K-means model using this particular function. Then from sklearn import metrics. So why should we import this metrics? This particular metrics submodule has majority of the evaluation functions. So what is the evaluation method that we are supposed to use with respect to clustering? Yesterday we discussed slide score. The range of slide score is -1 to 1. If the value of slide score is close to 1, then we can say that the clusters found are good. And with the value of slide score, if it is close to -1, we can say the clusters that are found are poor clusters, bad clusters, right? So that slide score function is available in this metrics submodule, which is present in sklearn. Okay, so what I'm doing is I'm importing all of them, the required libraries, functions in a single go. Done. Done. Then what is the next step? The next step is immediately I should have the data. For that, what I'm doing, I'm actually going and I go and copy the path where I have this particular data set mal underscore customers dot csv. So this particular CSV file is available in this particular location, and I'm assigning this path to an object called file path. So file path is a string because this is a string, right? So it's a string of size 42 characters. Okay, I'm storing the string in this file path, and this file path will be used in read underscore CSV. So far, what we have done, we have directly given the path inside read underscore CSV. So this is alternative. Either you go in that approach or this one. Both of the approaches will work. Okay, so this particular file path I'm using inside read underscore CSV from pandas, and this will read the data which is present in this mal underscore customers.csv file and stores the data in data variable. The variable, the object that we have used is data. So this is data. The same data set, friends. 200 by 5. 200 rows, 5 columns. Akhil, I see only 199 rows. 199? No, no, no. It's 199 index. Oh, it should be 200, right? Friend, in Python, by default, index starts from 0. So 0 to 199, it means 200. Okay, got it. Okay, so 5 columns. So these are the 5 columns and 200 rows. Good. Now comes, the data dictionary, whatever we have discussed so far. I kept it over the comments. As we discussed earlier, if you want to comment multiple lines, you have to use triple single quotations or triple double quotations. What if you want to comment only single line? It is single hashtag. Symbol that you have to use is hashtag, right? So for multiple lines, it is triple single or triple double. Okay, right. Head function. What does head function written as, friends? You have to become active. Use the chat and tell me what does head function written as. Head function will return the top records, right? So if you don't specify any number in the head function, by default it returns 5 records, the first 5 records. See, 0 to 4, the first 5 records of the data. Then info function. Info function will give you the complete information regarding the data set. Yes, it provides you information like, you know, uh, names of the columns, then the null value count, the data type. So it seems like there is no null values. If you see, all the columns have 200 non-null values. So we also have 200 rows. So that means there is no null value. And these are the data types. This is integer. All of them are integer except gender. Gender is like kind of object data type, which means it's a string, right? It means text. But now comes the question. What am I doing in line number 37? Think and tell me. This is not something new. So just think and tell me. I'm dropping customer ID. And what am I doing? I'm performing an in place operation. In place is equals to true represents, you know, within the same variable, I am going to drop this particular column called customer ID. Why am I dropping? Do you think customer ID will actually is it an important column? Can we include it in model building? What do you say, friends? Customer ID. It's a nominal data. No. So there is no use of having customer ID, right? So that is the reason I'm just dropping this column from the data. Now it becomes 4. 5 became 4. Then I'm also performing describe function. Describe function gives us the descriptive statistics for all the numeric columns. Out of 4 numeric columns, there are 3 numeric columns. I mean 4 columns. There are 3 numeric columns: age, annual income, and spending score. Count, mean, standard deviation, min, Q1, Q2, Q3, max. So what can you interpret from these particular values? What can you interpret? What can you understand? Actually, I can understand one thing. What? I see, you know, all these columns, they are not in a particular range. This is in one, the values are, with respect to age column, they are in 2-digit number. But with respect to, you know, annual income, I see 3-digit and 6-digit. Coming to spending score, 1-digit till 2-digit. So, out of these 3 columns, annual income has very big values. So, if that is the case, when you try to build a model on this data as it is, the model gets biased towards one specific column, that is annual income. So, what are we supposed to do? We are supposed to build model, but before that, we have to perform feature scaling. Feature scaling has to be done. The values, the data has to be scaled. Good. Right. Then value underscore counts. Data dot gender. This is representing the gender column. From that data frame, I'm actually working on gender column. On the gender column, I want to check the value and the counts. Value underscore counts will return the number of unique values for each and every category present in that column. Then the count of each and every unique category. So for male and female, it has to return the count. there are 112 female and 88 male. So when you sum up these two values, you'll get 200. Right? So 12 plus 88 is 100, 100 plus 100 is 200. Done. Then now comes, these are all the basic things that we generally do. The first step is EDA, right? So instead of doing manual EDA, which is time consuming, I just automated it using detail. We imported detail. Yes. So just two lines of code will give me the entire EDA output. Is that true, Akhil? Yes. Let me show you, friends. From detail, I'm using show function, and within the show function, I have to pass data. The data that I'm using has to be passed, and the results I'm storing to D, C. I'm clicking on execute button. See here, focus here, friends. It is under execution. It understands the complete data, okay, in the backend, and it stores the output. But we can't, understand anything when we go and open this D. But open this D in a browser. Open underscore browser is a function. So the results will be opened in a browser. See, this will be the output of detail. Where is the output actually? You are showing me the same data set. Hold on, friend. The output is here. Click on this arrow mark and you see here what is your interest. Do you want to check duplicates? Go. Remove duplicate columns. Remove duplicate rows. In general, we are supposed to remove duplicate rows, right? So let us check what operation that we want to do. Remove duplicate rows based on subset of columns. Yes. Keep the key parameter. By default, it is first. Yes. Let us keep first. Columns. Let us keep all the columns. Let us not select. Okay. Execute. Okay. Columns. Let me take age. Let me select all. All the columns. Taking all the columns. Okay. I want to go and check duplicates. So are there any duplicates? It will show us the duplicates also. Seems there are duplicates, friends, because you see 4 duplicates are present. You see here 4 duplicates are present. 200 became 196. That means there are 4 duplicates. But why are there duplicates? The reason is, in general, we cannot have duplicates in this data set. The reason is, in the first step, we removed customer ID. If you have focused, customer ID was removed. The customer ID is talking about the customer name, right? Obviously. So when you remove this, there might be 2 identical rows. Yes. But if you have this, you cannot have duplicates because it's a unique number, unique distinct number. Since it was removed, it is showing duplicates. If not, say if you want to visualize some charts, go with charts. What charts you want? I want to visualize a scatter plot. Okay, give value for x-axis, gender. Give value for age. See, this is my scatter plot for gender and age. Since I took a categorical value, let me take some numeric column. Age, annual column, annual income, the scatter. Can you see any kind of relation? There is no relation. There is no relation. So that is the reason it is the scatter is in a different way. I cannot interpret anything. If not, there are multiple charts. Bar chart. See, let me annual income and index. That's it. Because bar chart is a univariate chart. So you should have the column on the x-axis and this should be like index. That's it. You should not take any other column. It does not make any sense if you try to take two columns and visualize bar chart. I mean, one on x-axis, one on y-axis, right? So this detail help us to understand the results, in a detailed manner. Then missing analysis. Do you have any missing values? No. With respect to bar plot, it says there are no missing values. Every column has 200 values. So this is dendrogram, something which is not required for now. A matrix. So seems like there is no missing values. Right? Let me close it off. Then correlations. Do you find any kind of correlation? Select correlation is nothing but small r friends. If you don't want to select anything, this is the matrix. And small r works only for numeric friends. Okay, it works only for numeric columns. So obviously this will be 1. And if you see, all of the relations are less than zero point 0.4. What can you comment here? So there is, all the relations are weak relationships. Right? So in this way, you can interpret many things with respect to detail. Many things. See. Right? So an automated EDA package, within just 2-3 lines of code, you can get the output. But just to make our process very simple, we generally use automated EDA packages. But friends, if you are a fresher, if you are actually learning the process and all, it's better if you go and do the things manual. Don't go with the automated things, because you cannot generally learn anything in the first stage if you go with the automated things. Once if you became familiar, that's okay. But if you are not familiar, it doesn't make sense if you go and use, the automated things. Right. Then what I'm doing is I'm plotting a box plot for all the columns at a time. So this is my box plot for all the columns. Akhil, I see only box plot for 3 columns, but I have 4 columns, right? Hold on. Box plot cannot be visualized for non-numeric data. Then how come gender column? How can we visualize outliers on gender column? Impossible, right? So here I can clearly see in annual income column there is outlier, whereas in age and spending score, no. So should I handle the outlier or not? I'm coming in order, friend. Don't skip the order. That's what I told you. Just follow the order as it is. What is the first step? EDA. EDA is done. What is the second step? Data pre-processing. In data pre-processing, we have again 9 steps, right? So out of 9 steps, there are multiple. One by one has to be followed. So these two are actually representing data visualization. After EDA, we also perform data visualization, right? So I'm performing data visualization. This entire code is to create 3 plots. One is a count plot on gender column to clearly show you, to visualize what is the count of male and female. Then a histogram, a kernel density plot on age and annual income. So I can see that it's right skewed, and this is also probably right skewed annual income, right? So I'm just visualizing the data. I did not even start data pre-processing. All these are part of you know EDA. One is count plot. This is for the gender column, to show what is the count of gender, the categories present in the gender. And the next one is histogram, histoplot, Okay, so that is on age. Then the same is to plot on annual income. Right. Now the actual journey starts. Data pre-processing. Checking for null values. Do we have any null values? Anyways, we understood that there are no null values. But still, what I'm doing is I'm using the traditional logic, that is data dot is null dot sum. So this will return only boolean values, but dot sum will return the number of missing values present in each and every column. So there are zero null values. There is no missing value. So I need not work on the missing imputation and all. Let us go with outlier treatment. Okay. So the outlier treatment, the first step. What is the first step, friends? Typecasting, right? But I'm not performing typecasting. The reason is I don't want to change any of the data type. Then post typecasting, what do we have? We have handling duplicates. Do we have any duplicates? No. It's no. Don't say yes. The reason is we removed a column called customer ID, and just because of removing an unwanted feature, unwanted column, it shows rest of the columns. Using the rest of the columns, there are duplicates, but they are not duplicates because each and every record belongs to one customer. Since we removed, okay, now we can I get we might get duplicates, but still they are not duplicates. So I'm ignoring handling duplicates step as well. I'm just continuing with the third step, that is winsorization. I need not explain all these things because everyone is aware of all these steps, right? So which column has outliers? Annual income. So I have to initialize the winsorizer that was imported in the first case. Then using this winsor underscore IQR, I have to use it on the data, have to fit and get the transformed results, and these transformed results should be stored in the same column of data. Then post storing the transformed results, I'm again going and visualizing the box plot on the transformed data. Let us see, do we have outliers or not? The outliers got treated. There are no outliers. Clear? This is not something new. Whatever we have understood so far, I'm just clubbing all the things. That's it. Then encoding. So one hot encoder is being used. I'm dropping the first column. So I think this was also discussed. So even though if you drop the first column, that doesn't matter because when you encode the values using one hot encoder, the number of columns will be increased. Okay, so even though if the number of columns are increased, you can drop the first column. Okay, even though if you don't have the first column, you are able to interpret the results even though if you don't have the first column. So I'm just initializing one hot encoder, and this one hot encoder I'm trying to fit on the gender column. I'll get the transformed results, and I'm storing these transformed results in gender encoded. So let me open gender encoded. See. What is this? This is nothing but this represents males, gender underscore male. Why Akhil? Why can't it be gender female? That's what I told you, no? I'm dropping the first column. The first column will be gender female. Alphabetically, female comes first, right? So gender female will be dropped, and it will only hold gender male. So these gender male values which are encoded, I'm taking them and I'm also adding the column name, okay, from the gender, and I'm converting this to a data frame. Where am I storing it? Gender underscore encoded underscore df. See, it's a data frame. You will have a name for it. Gender underscore male. I think it's clear now. By default, it returns an array, friends. I'm converting this array to data frame by passing the column name. Okay, then this encoded gender column that we have, I'm concatenating with, you know, um, what the data, but within the data I'm dropping the gender. Okay, because this is no more required, because we have the encoded results. I'm concatenating the data and the encoded results by dropping the gender original column, and I'm storing in data final. So let me open data final also, where you will not find gender column no more. That was dropped and the new column was added. New column is nothing but gender name. Yeah, the alphabetical order by default female comes first, so it will be removed. So encoding is also done. Now I'll go with min-max scalar scaling. Okay, so I'm initializing the min-max scalar. Then on what columns I'm let me do one thing. Okay. So what I'm doing is, let me explain this first. I have initialized min-max scalar. So min-max scalar was stored in scalar. So I'm using the scalar min-max scalar. I'm fitting on the data and I'll get the transformed results. On what columns am I using? On all these numeric columns: age, annual income, spending score. And the results will be stored into the same column. Okay, so let me show you data final. See, previously we saw some big numbers. Now the data got scaled. Okay, now the data is ready for the model. Before I perform model building, I am cross-checking the results by performing describe. See the results. For all the columns, the minimum value will be 0 and the maximum value will be 1. So what can you interpret from this? I can say that each and every column has a value, minimum value as 0 and maximum value as 1. That means all the columns are brought to a specific scale. Now the third step comes into the picture. What is the third step? The third step is nothing but building a clustering model using K-means. For that, what am I doing? What am I defining, friends? What is this? I'm defining an empty list. See, inertia values is a list. What is the size? 0. Empty list. Then I am also coming up with k values, and these k values I am coming up with a range of values 2 comma 11. So that means k values will be started with from 2. It takes till 10. So you'll find this is an object, right? You cannot try and open a range object, but if you have a for loop, you can see what are the values present in this object. So from 2 till 10, all the values will be taken for k. K takes the values from 2 till 10. Now what I'm doing is, I'm coming up with a for loop. So within the for loop, I'm specifying, I'm building the k-means model using the k-means function. It takes, in each and every iteration, it takes different clusters. In the first iteration, it takes the value as 2. Okay, then it fits on the data and the results of within sum of squares will be added to this list. Append, right? So let me execute. In total, 9 iterations will be happened, and see it's done. Let me open inertia values. See, all these are within sum of squares. The average distance between the centroid and the data points with 2 clusters, 3 clusters, 4 clusters, so on till 10 clusters. Right. Then I'm trying to visualize with a plot. A scree plot has been built with two clusters within sum of squares. 3, 4, 5, 6, 7, 8, 9, 10. But if you see, from here to here, the line is steep. But if you see here, probably at 5 clusters, the line is getting parallel. Yeah, I see a straight line. There is no much drastical change. So probably we can go with 5 clusters, but still again we have a chance. Do you want to, because we have only 200 records, either we want to cluster them into 4 or 5. For that reason, I'm going to use knee locator. Knee locator suggests us how many clusters we have to go with. The same process, but using a knee locator in the place. Defining an empty list, then coming up with the same for loop, calculating the inertia scores. Okay, so using knee locator, so this knee locator actually helps us to take a call on the value of k. So it identifies the value of k, the best value of k. It says go with 8 clusters. The same plot, it says go with 8 clusters. But you tell me, friends, 200 records, 200 customers, should I group them into 8 clusters? Probably no. The reason is why it is suggesting 8 is within sum of squares, the inertia that you have here, it's getting reduced as number of clusters are increasing. 2, 3, 4, 5, so on. What's happening to the within sum of squares? It is decreasing. So wherever we have the minimal within sum of squares, it is suggesting those many number of clusters. So it is not done in a proper way. I'll just ignore the knee locator. I'll go and build with 4 clusters. I'm building a model with 4 clusters. Okay. So I'm initializing k-means with 4 clusters, and upfront I'm defining. You see, that's what we have understood. In k-means upfront you have to define. Right. So once if it is initialized, I'll take this k-means function, I'll fit it on the data, and I'm storing the results in xy. Okay, so I'll get the labels using an attribute labels underscore. Since I have kept it as 4 clusters, these are my labels for the 200 records. From 0, 0 is 1 cluster, 1 is 1 cluster, 2 is 1 cluster, 3 is 1 cluster. In total 4 clusters. 200 rows fall into what clusters? These are the numbers. Okay, so I have all the cluster IDs for all the records. Then what am I doing? I'm just proceeding to the next step, calculating Selite score. For the given number of clusters, Selite score, is it good or bad? 0.35 is what I have achieved. So it's like moderate. I did not got a value which is close to 1. In the same way, I did not get a value which is close to -1. If I group the data into 4 clusters, that means probably the Selite score is 0.35. It's not close to 1. In the same way, it's not close to 0 as well. A bit close to 0, but still we have to improve it. What are the other techniques we also have? There are multiple evaluation metrics. As we have discussed yesterday, there are multiple. We just understood only Selite score. There is Kalinski-Harbach score, Davis-Baldwin score, then Rand index, Baldwin index. They're like this. There are multiple, evaluation metrics, friends. So just as an experiment, let us also try out with Kalinski-Harbach score, and this will tell you again, if you get a higher value for Kalinski-Harbach, then we can say the clusters that are formed are good. We got 182. Okay, with respect to Kalinski-Harbach. Davis-Baldwin, the value should be low. It is 1.1115. Okay, so out of these three, you stick to one. In general, we'll stick to Siloid score. So Siloid score is enough. So let us stick to Siloid score. And then what I'm doing is I'll make all these labels to a series. Series is nothing but a single column. Okay, the cluster IDs I'm converting it to a series and I'm storing into a object called a variable called labels. See, all of these will have 200 by default. So these are the different cluster IDs that we have. Okay, then what I'm doing, I'm concatenating the labels and the data, original data, where I'm storing data underscore cluster. This is my original data. To the original data, I'm concatenating the cluster ID. So record 1 falls under cluster 2. Record 2 also falls under cluster 2. In the same way, you can segregate. See, so these are the records, they fall under cluster 0, then 1, then 2, then 3. Okay, right. What? What am I doing? Now I'm just calculating the average. See, I'm taking this data frame, then within this data frame, take all rows, but from column, from index to 0, 1, 2. From here, calculate the averages for these three columns. Why am I calculating averages? Before that, group by data underscore cluster. In this data frame, we have cluster ID. So based on the cluster ID, group the records, then calculate the mean and store the values in cluster average. Cluster ID is not defined. Oh, sorry, I did not run this particular line. I'm renaming this zero that I have. I have it zero, right? I'm renaming this zero with cluster ID. Okay, then I'm getting the averages because if I get the averages, I can talk on the clusters. See, so four clusters I have brought up with. I have come up with four clusters. So cluster zero, the average age is 28. What is their annual income? $60,000 annual average income. On an average, these folks they get paid $60,000. And what is the spending score? 67. It's good. So they are getting huge. They are also spending huge. Proper. Now let us come to cluster one. What is their age? 48. Close to 50. Yes. If you see here, probably they're also getting more. The same. Excuse me. They're also getting, in a similar fashion, they're getting paid. But what's happening to their spending score? Are they spending huge? No. It's just 34. Why? What is the reason? So we'll target these folks by giving offers because they're getting huge pay, but still their pay, their spending is very less. Even these people also, their age is 49, average age. They are spending more. They are getting paid more, but spending very less. So when you do segmentation, you can get all these insights. Now you target. So take a customer randomly and take the customers of this cluster and this cluster. Okay, why are actually they are not investing? Why are they are not spending their income? What is actually stopping them? Okay, you can do some kind of survey or some kind of you can come up with some bundle offers to attract your to increase your profits, to increase their spending score. You can come up with multiple strategies. What about these clusters then? Obviously, these two are same, right? So instead of four, if I make it three, so these two will be clubbed, I think, right? So for them, these people are actually giving you profits, friend, because if you see, they are spending very huge, 7167. They are spending very huge. So because of their spending, we are getting profits. So you can come up with kind of one plus one offer you can give for them, so that they'll spend still ready to spend more, right? So depending on these output, you can take a call, right? So this is how we actually do clustering. Just as an example, we have done, and to be frank, the Silite score that we have got is very less, and in real time, they don't accept the Silite score. Probably it should be greater than zero point 0.6, zero point 0.7. Okay, just as an use case, we are defining it. Okay, as a project, we have understood how K-means work for customer segmentation. Then, what am I doing this? I'm saving that data to a CSV file with the name KMeans underscore mall underscore customers dot CSV. Okay, so with this particular name, I'm storing the data. Okay, and this data will be readily available in your current working directory. In this directory, in this particular path, you will have the data stored in a CSV file. Let me show it to you. So this is my current working directory, and just what is the time now? It's 8:17. See, now you take a filter. You apply a filter, you'll get the required whatever the clusters you want. You can actually filter based on that, right? So I'll stop it here. I don't want to drag more. So this marks the end of project on KMeans. Tomorrow we'll start with a new algorithm called KNN. It is part of supervised learning, and we'll do predictions there. Okay, so that's how we are going to cop up with the next in the coming 3 days. Correct. So it's time for our questions. Do you have any questions, friends? Attendance. So, guys, just give me a minute. I hope you have, you have understood the particular concept. Yeah, and the way how we have, you know, came up with all the techniques on the use case, whatever we have understood. Okay, we were able to apply all the techniques on the use case. In the similar way, when you try to do it on a data set, you'll understand how uh, the particular algorithms work. So it's better if you do an hands-on with respect to any of the data set. You'll learn more instead of just watching or just listening, right? So go with hands-on. Does the number of clusters affect the efficiency if the model on the model we built? Yeah, yeah, sure, definitely. That's what. See, when I try to build the same model using 10 clusters, my Silite score will be negative also. So that's why you take the call on the K value. And moreover, the K that you are going to come up with the number of clusters. Okay, so you have to upfront map with your use case. See, you just had 200 customers, and what is the use of grouping these 200 customers into 10 clusters? It doesn't make sense. Probably four, if not five, maximum five. Okay, so these five clusters, you have to focus on these five clusters and increase your profits. I'm talking about the domain. Okay, so with respect to the domain, you have to map. Yes. So any other questions, friends? Probably we are not going to share any kind of attendance link for the day. Okay. Minimum cluster we can form two. Minimum will be two. One cannot be done, right, my friend? So minimum will be two, and two if it is making sense. Yes. If not, you can go with the required number of clusters depending on the use case, depending on the client, you know, depending on the domain. Yes, you take a call. Thank you so much. The session is very informative. Okay. We discussed already. Any suggestions for deciding the cluster number? See, cluster number is decided based on multiple factors. One is domain knowledge. The project that you are actually working on, it has a domain, right? So using the domain knowledge, you can fix the number of clusters. If not, client's requirement. If the client is having any requirement that you have to go with only these many number of clusters, you have to go with that key value. If not, go with elbow curve. If not, go with Silat score. So there are multiple ways for deciding key. If you have did not attend yesterday's session, just go through the yesterday's session. You'll get a clear idea on how to fix the number of clusters. Yep. So friends, probably we are not. I think we are unable to share the feedback link for the day. But before you leave, just hit on the like button. Anyhow the attendance will be tracked by, we anyways will have the chart, right? Whoever folks have responded, will take the attendance, will capture the attendance from this particular chart. And before you leave, just hit on the like button. Also share it with your friends, your relatives, whomever it might be. Ask them to, okay guys, don't leave, the attendance link has been shared. Okay, so just give your valuable feedback. Go and fill that form. The attendance link has been shared. Give your valuable feedback, then leave. But before you leave, hit on the like button. If you have any kind of questions, keep it on the chat. Even if you are listening to this particular session, might be in a couple of days later, still use the comment section to post your questions. Majority of you are using the comment section. That's great. Yep. So if you're done, thank you so much, friends. We'll connect tomorrow and we'll discuss a new topic. Thank you so much for joining today. We'll continue with the next topic the next day. Until then, take care. Have a great day. Bye. Signing off.